All right, we're back. We are still, what are we doing? We're on page 3 of notes 12 of Calc AB. We've done half of it. We did all this geometry, which is really like the key to these. You'll find they're just like weird geometry area problems with like a little context to them and like some new notation. But if you can convince yourself that these are just kind of fun geometry problems, they're not really that bad. So we found all of these last time. We had a GeoGebra thing that was helping us to check. Now we're going to do some slightly different things. So the first one that we're going to do is asking us, so think about what this is asking us. It's saying, take the app, there is just a plane flying over that is so low. I don't know if you can hear that. It's crazy. Like what could be happening? I don't know. Well, I hope it's not like all you can hear, but I'm going to keep talking. So this is saying, find the absolute value, right? That's what these are doing, of whatever this is. But remember, this thing is a number. So this is a number, and we're going to find the absolute value of a number. So what number are we finding the absolute value of? We're finding the absolute value of, well, positive 9. So that's a stupid problem. But, so it's just 9. But keep in mind that if it had been the absolute value of, so if say it was the absolute value of, okay, here, right? So if I had done a separate problem, if I had done the absolute value of the integral from -2 to 1 of f of x dx, that would have been the absolute value of the -6 that is that number. So it would have been 6. So this would have been a better problem for sure, and maybe I'll replace it. Maybe by the time you're looking at the notes, it'll be different, but I doubt it. So this one was saying, find a number, take its absolute value. The next question is actually different. So this one, there's still absolute value, but it's saying find the integral from -6, what is it doing? The integral from -6 to 8 of the absolute value of f of x dx. So the absolute value of f of x dx is an important idea, right? So this, the absolute value of f of x is, we're going to reflect all negative parts above the axis, right? So that's what we're going to do. So you don't get any negative regions. So if we go back to the graph, so what were we going from? -6 to 8. Okay. So here we're going all, oh, that's the full thing. The absolute value of f of x. This is the graph of f of x. Right? That's the graph of f of x. So f of x is already positive here, and it's already positive here. We're going to do the absolute value. So what happens is this part reflects up. So you end up with this, and then, I don't know, here probably, and then here, and then here, right? Ugh, gross. You know what I'll do? I'm going to draw it in orange. So it'll be here, and then where's the next like point? So it's going to go here, and then you're going to go here, and then you're going to go here. And then I'm going to fix this one so that it looks nicer. There. So this graph, now everything above the axis, this is the graph of the absolute value of f of x. So we want to find the definite integral of that graph from -6 to 8. But we kind of did the work, right? Because we figured this out, and we figured this out. And actually, the way we did this one problem, where we did just the positives, and we got 18, then we did just the negatives, and we got -9. Well, we just took our -9 and reflected it up here, which means this now is going to be +9, right? The full thing here is +9. So we're going to do this 18 plus this 9. So we're going to get 27. So it's going to be 18 plus 9. I'm going to write it in this color. So I think we're going to get 27. I hope we get 27. I'm pretty sure we do. All right. So the next question is equally kind of strange. So we're going from -6 to -4, fine, of f prime. So of f prime, well, what is f prime? So -6 to -4 of f prime. -6 to -4 is here. So this is f of x. So f prime is the slope of that, and we're going down 1 over 2, so -1/2. So we're going, we're really doing the integral. We're really trying to do the integral from -6 to -4 of -1/2 dx. Okay, but what's that? So that, in my mind, is going to be a rectangle that has a base of 2, because you're going from -6 to -4, and a height of -1/2, and then it's a rectangle. So, I mean, whatever, I tried. That didn't work. Why aren't you auto-ing yourself? There we go. So if I add those together, I just get -1. Add them, what? Multiply them together, and you get -1. The weird thing is I did it right. I just like totally had the wrong concept. So now what's another way we could think about this, right? So let's say f is position, then f prime would be velocity, right? Because the derivative position is velocity. So I'm integrating velocity from -6 to -4. If I integrate velocity, that should give me displacement. It should give me the total change in position, right? The net change, the change in position, right? So if we think of this as velocity, it's the velocity of f. So integrating this should give me the displacement of f. What's the change in f from -6 to -4? If we go to the graph and we look at the change in f from -6 to -4, f was here and now it's here. The change is down 1, -1. So if we go back and we see, we actually got -1. There's actually 2 ways we could do this. So here, let's try to think this one through, right? So if I say that f prime of x is the velocity of f of x. It's really the rate of change of f of x, but like the problems we did before were about velocity, so like it makes sense to kind of contextualize it that way. So we're gonna say it's the velocity of f of x, which means that the integral from 3 to 4 of f prime of x dx is the displacement of f of x, right? It's the change in f of x, the signed change, either positive or negative, on 3 to 4. So let's go to the graph and see what happens from 3 to 4. So we're going to look at the graph of f of x, and between 3 and 4, 3 to 4, the value goes from 0 up to 3. I think this answer is going to be 3. We're going to do it 2 different ways, but I'm saying based on this logic, we're going to get 3. The other logic is we just find f prime and treat it like a rectangle. So f prime between 3 and 4, if you go over 1 and up 3, so f prime on this interval is 3, because that's the slope. So if we do the integral from 3 to 4 of 3, that's going to be a rectangle that has a base of 3 and a height of 1. What am I doing? That's wrong. It's not wrong, but it's not right. It has a base of 1 and a height of 3. Trying to make a rectangle. Rectangles are hard. 3, which is exactly the answer that we got. So it actually doesn't matter which way we interpret it, we'll get the same answer. So I'm going to look at both of the next two in kind of the same light. So 4 to 6 of f prime. 4 to 6 of f prime is like finding the displacement of f of x from 4 to 6. So I need to know where it was at, well, I figure out where it is at 6, where it was at 4, and I do like where f of 6 minus f of 4, basically. That's how I'm going to find my displacement. So this should be f of 6 minus f of 4. Let's see what that gives me, and then we'll do it the other way. F of 6 minus f of 4. F of 6 is 4, f of 4 is 3. 4 minus 3 is 1. So 4 minus 3, which is 1. Now let's go back and find f prime. So 4 to 6. So f prime is going to be the slope between 4 and 6. So 4 to 6. You go, oh no. You go over 2 and up 1 over 2. So 1/2. So we do the definite integral of 1/2. I think of that as a rectangle that is, the base is 2 and the height is 1/2, which gives us 1. We get the same answer either way. Doesn't make a difference. I mean, it makes a difference in the way you think about it, but like not really in general. So if I'm finding the displacement of that, I'm integrating the derivative, right? I'm integrating the velocity. It should give me the displacement. Displacement is where you end up minus where you start. So this should give me f of 8 is where I end up. F of 6 is where I start. This is my displacement. Oh my God, AutoShape, what are you doing? Jumping in. So this is my displacement. So let's see what f of 8 and f of 6 are. F of 8 is 2, f of 6 is 4. So 2 minus 4 is -2. And like I find this really, it's like really exciting. What was it? 2 minus 4, -2. Okay, because it's a clear connection. There's like a weird connection going on here where we have like, you know, our displacement can be looked at 2 different ways, right? You can just do like the rate times the time and get displacement, or you can do like where you end up minus where you start and get displacement. 2 completely different levels of thinking of it, but they both work, and that is amazing to me. So this will be 6 to 8. I need to know what f prime is. It's negative something. Down to over to -1. Okay, -1. So I think of this as a rectangle that has a base of 8 minus 6 is 2, and a height of -1, which is -2. And then the beauty of it, I mean, look at that. -2 this way, got -2 this way. You'll get the same answer no matter how you do it, which is very, very cool. Okay, so I think we're done with this. This is a big page. Like, I don't know, man. Print out another copy, maybe blank, and try to do it. It's getting really dark in here. It's like 2:30 in the afternoon, so maybe we're gonna have some storms. Who knows? But anyway, all right. I'm gonna call it for this video. I'll be back in the next video to do some more, and I will see you there.